In question number 8, we now want to evaluate the definite integral, the integral from -1 to 1 of t squared plus 2 dt. In order to do this, we're going to use the fundamental theorem of calculus, which says you first need to find an antiderivative of t squared plus 2t. To do this, we can do the power rule. The antiderivative of t squared, you add 1 to the power, divide by the new power. That's going to be t cubed over 3. The derivative of 2 is going to be 2t. And then we need to evaluate this from -1 to 1. The fundamental theorem of calculus says you first evaluate the antiderivative at the upper bound. So I'm going to plug 1 into my antiderivative. And then we need to subtract the antiderivative evaluated at the lower limit of integration. This will give us our answer. It's going to be 1 over 3 plus 2 minus, this is a -1 over 3 minus 2. And instead of combining things in the parentheses, it's probably going to make the arithmetic a little bit easier if you just distribute to get rid of the minus sign. This would become a plus 1/3 plus 2, which gives us 2/3 plus 4. If you want to, you can get a common denominator. This would be 2/3 plus 12/3, which would be the value 14/3. Remember, this was a definite integral because we had limits of integration. So the answer to a problem like this is not a function, it's going to be a number. So when you do the antiderivative, you do not need to do the plus c on this. You just find a basic antiderivative, leave the c off, evaluate the antiderivative at the upper bound, subtract the antiderivative at the lower bound, and that gives you the value of your definite integral.